Welcome back to DevOps Pro Conference 2022. I'm Kevin Jacob, DevOps consultant at FE Code, and we have Ron Ekins, field principal solution architect. And Ron will introduce Kubernetes and show us how can use the Oracle Kubernetes operators to us. And over to you, Ron. It's all yours right now.
Okay, thank you,
Uh,
Kevin.
Please do share your screen, and I'll let you know when it's visible. Meanwhile, I encourage all our audience to use the Q&A tab and chat tab so that we'll take the question soon after presentation from Ron is done. Ron, your screen is visible. We're ready to go.
Thank you. Hopefully, I'm coming through loud and strong. So thank you for everyone for attending my the session this morning or this afternoon, depending on where you're watching this from. So today's session, getting started with Oracle and Kubernetes. So as Kevin introduced me, my name's Ron Ekins. I'm a principal field solution architect working in the office of CTO at Pure Storage. There's my Twitter handle and my blog, ronekins.com. So lots of Oracle content there, lots of Kubernetes content, lots of DevOps content there. So if you're interested, pop over there and hopefully read some articles. I do try and keep it fresh. I do try to publish an article every couple of weeks. I'm an Oracle ACE director, so it's a community award. I'm also a TOGAF certified enterprise architect and cloud architect. I'll put my my Twitter handle and my blog in the chat. So if you didn't catch that or you want to follow me while we're doing this, you got that there. So you can follow me and visit my blog. I'll put that out there for you. So today we're going to just quickly touch on Docker and Kubernetes, make sure we're all in the same place, and then why containerized database. I'll give you a bit of information about what Oracle's doing in the container space and how databases change the way we consider application deployed in Kubernetes and containers specifically. About persistent storage. We'll look at that, and then I'll show you how we can build and deploy a database, and then we'll finish with the brand new Oracle Kubernetes database operator. So I've got a lot to cover, so I'm going to go quite quick. But please put questions in the chat box, and I'll try and take those as we're seeing. So we're in the Q&A section. So Docker and Kubernetes. So Docker and Kubernetes are related. Sometimes it gets confusing about, are they competing? Well, no, they're complementary technologies. So the container platform and the orchestrator work in harmony. And that's why we see the idea of the orchestrator. He pulls all of the components together in the orchestra. And that's what Kubernetes is doing for us. So it manages work placement, managing state, starting things up, shutting things down, and keeping things up. So it manages the health of our cluster. It looks and sorts out load balancing of services on our behalf. It manages networking and, critically for databases, persistent storage. It's a declarative mode, and what that means is Kubernetes' job is to make the desired state the actual state. So we tell it what we want, and then the cluster is managed on our behalf by the Kubernetes processes to deliver that actual state. So Docker versus Kubernetes, it's not so much of a versus, it's that they come together. So let's just make sure that we understand that Docker is the container platform and Kubernetes is the container orchestration platform. And there are other container platforms and there are other orchestration platforms. So why should we be talking about containerization? So containerization has been popular in the application space, but it's getting very popular in the database space. And what we can see from this report that's up on NewStack is that now databases are the top workloads in Kubernetes. So we're seeing this led by open source databases like MySQL and Mongo and Postgres, but other databases also coming into that area as well. And then further down, we can see login and analytics and web servers. which maybe we would have thought been at the top of the list, but now it's databases. But why should we be deploying databases on containers? Why particularly Oracle? Well, the reason we would want to put our databases into containers, because it allows our developers to spin up databases with minimal resources. It lets us deploy a database without having to think about the complexity of operating systems, database patching, configuration and management of the environment. It lets the application developers focus on the code rather than the infrastructure. Critically, it has to be supported and licensable for the enterprise. And Oracle is able to do this for us. It's an enabler for database as a service. It provides data mobility and persistence. If we're having our database, it's critical data often. And we want to make sure that data persists outside the life of a container. More importantly, it runs everywhere, on premises in the cloud. And there's just a few of the cloud vendors over there on the right-hand side. So if we deploy a database in a container, we should be able to take it to any cloud and it should work the same. Very powerful. So what's Oracle been doing in the container space over the last few years? So actually, Oracle's been doing container support for quite a long time. It's been probably unseen. They've actually had a Docker image, which is no longer available in Docker Hub for over 5 years. So 4 years ago, we had Oracle 12.2, and prior to that, we had 12.1. If you want those versions, you'd now go to the container registry. So container-registry.oracle.com is where Oracle now distributes its images. If you go to the container registry, you will see the latest version of this, probably the most common version today for Oracle is Oracle 19c. And if you want to take the newest version, the innovation release 21c, that's also available in container registry. So using your Oracle single sign-on credentials, you can navigate to container registry, and then you can look into the repositories. And so click on Enterprise, and there you'll see Express Edition of the database or the Standard Edition too. So different versions depending on your license requirements and your environment requirements. So you can pick your image there, and you can see that image and pull that back. However, if you haven't got the images that you need, so there's only 21 and 19c there, you can also build your own Docker image. So Oracle has a set of scripts. It requires the Oracle base image, the RPM, for you to use this to put it into it, but it creates a Docker image on your behalf. So that's available in GitHub. So navigate to that location down the bottom, and you'll see the scripts there. So pull those back, and you can use those then to build a 21c Enterprise Edition, Standard Edition 2, 19c Enterprise Edition, Standard Edition 2 again, as well as 18c Express Edition and 18c, 12c Release 2, Release 1, and the very old Oracle 11g Release 2. So we can actually create images now, Docker images of previous versions, and which is great from a support point of view. So we can actually spin up an old database version if required, as well as the latest and greatest 21c. MySQL, that's also has support. That's also from Oracle, and Oracle has a Docker image for there, and you can see that through the My Oracle support. They also have a database operator, which is available as well. So considering support and licensing, so where does Oracle stand on this? So actually, from a support point of view, Oracle's been supporting Docker for many years, right back to 12.1. And you can do this in production and non-production for single instance. Oracle RAC has some caveats. That was only previously allowed to be done in single instance. However, with 21.3, we can now run Oracle RAC in production. So there we have Oracle 21.3 in production, 19, 18, and 12 dev test for RAC. Single instance is supported in production for all database versions. What about licensing? Oracle is able to support containerized environments, very similar to the way it supports virtualization machines. So you have to license the underlying host. which can become complex in a containerized environment, where if you have a Kubernetes cluster of 10 nodes, 50 nodes, 100 nodes, that could be a lot of licenses to worry about. So what you do is you can use containers, topology rules to actually control where your database runs. And this white paper details how you can configure topology rules to make sure that you're license compliant. Oracle Express Edition is a community edition, a developer edition, and you're free to use that to wherever. Enterprise Edition has some restrictions which you have to follow. One advice when you're looking at Oracle databases, always make sure that you go to a trusted source, always go to Oracle. Don't take images from a GitHub repository because you're not quite sure who created that image and what's inside it. So always know the source of an image. So that's true for the Oracle database as well as other applications databases. The need for persistent storage. So containers and databases. So I said, databases are now becoming really popular. But for some people that in container space, it doesn't fit easy for them. They, as a purist, they'll say a container should be stateless. It should only have a short lifespan, minutes, hours, or days. Treated like plants. If one dies, you just get another, location independent. Don't generally use local storage. You have floating IP address, floating names. It's very different to a database. Tend to be lightweight, don't consume much memory or have much network or storage I/O. So very different to a database workload. But what we've seen in the last few years now is, databases are really good for containerization. Some of the reasons why we containerize applications are still true for databases. However, a database is stateful by design. If we want to store something, we want it to retain. Also, we'd probably like to have that database hanging around for a lot longer, hours, days, or even years. It's a very different life cycle to a traditional container. DBAs and data professionals treat a database like a member of the family. They protect it at all costs. The cattle idea is not quite the same. We look after our databases. We have to look sure they're backed up. We have to make sure they're secure. So we have to treat them slightly differently. Databases historically being location specific. A DBA would know what server it runs on. They would know the connection string. They would need to know the storage, and the storage could either be local or NFS or SAN attached storage, but it was tied to the server. Usually a fixed IP address and host name. Heavyweight, lots of memory, gigabytes or terabytes of memory, lots of network I/O, lots of storage I/O. So very different to our traditional container workloads. However, with persistent storage, we can now deliver databases successfully. Databases need persistent storage. They need to have that idea that our data is secure and it's going to persist outside the lifespan of a container. So this is where the CSI comes in, the container storage interface. This standard allows us to manage our storage. It allows us to provision volumes on demand, dynamically, create them and extend them. It lets us take snapshots. We can take a snapshot of a volume. We can use that snapshot to clone or for protection. Cloning volumes is really powerful in the database space. We want to be able to create database clones. So we can use storage snapshots of this all through the CSI interface. From a database point of view, we also need different access methods. And this is possible with CSI as well. So we can have read write once, and this could be for our single instance databases, where the volume is only mounted on one server at a time, and that has read write access. Read only many. This could be good for a shared system where it's a log file that has lots of access, but it can only be read. It can't be written to. And read write many. This is required for applications which need to have a shared environment. This is easy with NFS. It's a little bit harder with block. And this is where we would have our RAP database. We should use an Oracle ASM for read write many. So the volume can be mounted as a read-write device by many hosts. Now, CSI supports both block and file protocols. So we can deliver all our databases, whether they be file system or block technologies like Oracle ASM through CSI. So let's think about dynamic provisioning. What would it look like? So on our database, we have some volume mounts. These are defined in our manuscript. The volume mounts reference volumes, and their PVC has a claim name there. Persistent volume claim asks for a size as a selector and a storage class. The storage class tells Kubernetes where to find the volume, what storage platform to use, what type of storage it should be used. It can make decisions on performance, on the characteristics and replication. But if ultimately it points to some physical storage, whether that be NFS or block. And dynamic provisioning means that it can create the volume on demand and make that available to our Kubernetes environment. What we want to be able to see in a database. So let me walk you through how you can build a containerized Oracle database. We start off by creating a dedicated Kubernetes namespace. Then we create a secret for our Oracle registry. We're about to pull our image from the Oracle container registry. So we need a secret for that. This is our Oracle single sign-on credentials. We then create a configuration map. It's one method of doing this, where we can set our database variables and options, database name, database passwords, etc. Tell it how we want to configure our database. These are going to be the inputs to our image. And then we can create an Oracle 19c database. Okay. Very simply, to create a namespace, create a YAML file. Here I created a YAML file, namespace.yaml, and I'm going to create a namespace called Oracle namespace. So I can apply that, kube control apply -f, and then that creates our namespace. We now need to create a secret to connect to our Oracle registry. So kube control create secret, and it sees the syntax there is Docker registry. So I've got my secret, I'm going to get a name OCR secret, but rather than saying Docker hub, I'm pointing this to the container registry.oracle.com, providing username, password, which is my Oracle single sign-on credentials, and this is going to create me a secret. Once I have a secret in place, I can look at a configuration map. So in my GitHub repository, I have support for different versions of Oracle, Oracle 12, 18, 19, etc. And they have slightly different configurations and slightly different environment variables depending on the version of Oracle, the way the image was created and moved. And we can see here that Oracle 12, it used a variable called dbsid. Oracle 18 had the same, but Oracle 19 changed it to Oracle SID. DBPDB got renamed to Oracle PDB. Bundle got changed to Edition. So the syntax changed. So what I have is a common configuration file, which I can use for all my database environments. So I have this file. I can edit this and add additional information. Likewise, there are some optional values, which I'll set the SGA and PGA size if I want to. So I have my configuration file. I can apply that with kube control create, and then read that environmental file from the operating system. So that's going to create me a config file. I now want to create some persistent volume claims. I want to define them. So the Oracle image expects 3 different volumes. One called startup, one called setup, and one for data. These are built into the Oracle image. So you've got a volume claim template here. Here I specified the name, the size, access mode, rewrite once, and the storage class there. So the data is 20 gig, the others are 1 gig. The startup is only used with the volume is started. It looks, the container image scripts looking at for scripts to run on the startup. Setup is a once-off only. So if you use a script you want to run on the initial creation, you put that in the setup. Anything you want to run on the startup, you put it in there. We have our data living in the data volume. So here I have a storage class. So here I'm specifying replication, IO profile, and availability, and also allow expansion equals true. So I have got some rules that I can have against my storage. So it knows where to find the storage, what the provisioner is, and is the performance requirements. So here I've defined my storage class, and I've told my persistent volume claims to use it. So I can apply this, and this is going to create me my database. So I have this in my GitHub repository. So kube control apply minus F 19C stateful set PX. This is going to create my database. So what do we need to be able to do from our database? We need to be able to shut it down and start it up. We could do this with a deployment with scale. So replicas equals 0 to 1. That would scale the database up or down. We can also do the same with stateful set, same. So Oracle 18C, I've got a script for that. I've got one for 19C, same replicas. We can delete the database by deleting the stateful set or deleting the deployment. Relocate move. So one way of doing this is to use cordon. So we can cordon a node, make that node unavailable. Maybe we want to do some maintenance on that worker node. We can then kill the pod, and it will get restarted on a different node. Once we've done our maintenance, we can make that node available to the pool again by uncordoning it. So one thing I'd always advise to people that work in the database space is to avoid hard coding. So use kube control to help you do this. So to get the database, list the port, get the services, and then navigate the services. So filtering here for port equals 1521, and this is going to give me the external port number, which I can use for my database. To get the Oracle SID, we can query the config map. So here I'm saying, give me the database name, and that's going to return the database name. Give me the port, so 1521, and there's the external port. Okay. I haven't got the time for a live demo. It takes over half hour to create a database on my environment. So in my lab, I'm going to show you a quick video of how this would work, and we'll talk through what you're seeing. So here's my scripts, my YAML files, you can see there. So first of all, I create my namespace. There's my properties file. So we'll look at here. So I'll create my config map. So here I'll specify the database version, the Oracle SID, and the PDB name. I've got no persistent volume claims at the moment. I've got an empty environment. So let's see any services. There's no services up. So let's create our database. This is going to create a namespace. It's going to create a stateful set and the services. Here we can see the pod's been created. It's pending. If I see the nodes, I can see how many nodes I have. I have 7 nodes in my cluster. And I can see that this pod has been started on node 6. And the status is now running. There's the mapping of the IP address to the port 1521 external port. There's my persistent volume claim. So it's created my persistent volume claims dynamically for me. So the data plus the setup and startup. To look at our database, we can watch the creation or using follow. And here we'll see the database creating going for you. So the initial Oracle creation takes a while. It has to establish all the data files, and we can see this moving on. So this is an accelerated video to make it a bit more interesting. We won't want to sit here for a half hour watching this go through. So here you can see the database has started, the process is running, and we're up, moving on. We will see the container database start, and then it will move on to the pluggable database. So what we've seen here is the stateful set has created our services, it's created our persistent volume claims, and now it's pulled the image back, and it's now creating a database for us. %, 43%. And that's the database creation. So this is the container database created. And the container database is an Oracle term rather than a Kubernetes term. So the container database is created, and now it's going to create the pluggable databases which reside in a container database. So it moves on to up to 50%. Very quickly, it will move on again. And then we will get to a point where it's 100% and we're able to connect to the database through the Oracle listener. What is interesting here is we'll see that the script has moved on, so we can see the version of Oracle. We can see the database is ready to use, and it's finished. So the state is there. Now going back to my out of the log file, we can do kube control get services, and there's a service. There's my database name and the port. So node port is being mapped onto 31509. So I can grab that, use that as my destination port. And then for my desktop, I can connect to my database. And from this point, it looks and feels like any other database. One thing I guess is worth highlighting there, the host name is the pod name, not the worker node name. So I can connect to any node in my cluster, and the node port maps it through the port to actually the worker node. So I don't need to know which worker node it's running on, is able to be found. So that's using stateful set. However, there are easy ways to deploy a database, and Oracle has recently released a Helm package. So the Helm packages call the database images on our behalf. It's a way of describing the database. So we install Helm and configure that. Then we can install the Helm chart from Oracle, which is available on GitHub, and we can customize that and localize that. So very simply, we have a Helm available in GitHub. So here I've cloned this back from the Oracle section on GitHub. I've then used Helm to package up and create a Helm chart. I then have a file called values.yaml, which is my customization file, very similar to the one I showed earlier. So we just update the YAML file to give the database name that we might want to use and some other settings. Dry run to make sure the syntax is correct and there's no typos in there. And then Helm install database 19c, the pointing the F, the values file, and then the image which was packaged up there, and we can do that. And then that's going to be a nice simple way of creating a database in one line. I've documented this in my GitHub, so if you want to actually explore using Helm with Oracle, visit my site, look at that, and then there was a step-by-step guide on how to use Helm with a database. Moving forward, Oracle has adopted database operators. Database operators have become more and more popular. If we go to other databases, you'll see multiple operators. Oracle has the only Oracle operator, whereas MySQL, there is an Oracle MySQL operator, and there's other third-party operators from like providers, for example, like Pacona. But what is a database operator? You know, an operator is a way of packaging and deploying Kubernetes applications. It's a way of helping us deploy in a consistent manner. It gives us features to allow us to do lifecycle management. And we should be able to use an operator to deploy a database or application within the cloud or on premises in the same way and across different cloud vendors. So it becomes a very powerful way of distributing a application or database, because we can have a common way of deploying with a common set of commands. So Oracle's been working on this database operator. The name, if you're searching for the internet, is operator. However, today it's not for production use, so it's a great way to explore and get used to using operators for development and test. But where it's maybe slightly different to some other operators, it's realized that your data might not always be in a container. So the Oracle database operator is going to be able to manage containerized databases and traditional databases. And these databases could be even in the cloud and database service like the autonomous database, or on-premise database, traditional databases. So using kube control and the database operator features, we can manage any databases regardless of how they're stored or where they're stored. So I've got a blog on this as well, and I've got a Terraform script which can deploy an OKE engine. So this is the Oracle Container Engine into OCI, the Oracle Cloud Infrastructure, and deploy a database. So you might want to read that if you're interested about how you can get started with OKE. Use the UI, but eventually you might want to automate that with Terraformer. So have a look at that. Once you've got Terraformer in place, you might want to look at deploying Oracle. And I've also documented that. So how to deploy a database into containers. So that's what I wanted to share with you today. I'm going to go over to the chat box now and see if there's any questions being raised while we've been speaking. So, Valentinus, hello. What is the benefit adding that much effort starting storage in Kubernetes when you can use cloud versions of storage and access it from Kubernetes? So the deployment I had was using OKE. I've created I'm using the Portworx storage there to provision storage automatically for me. When we're using Helm, when we're using the operator, it does automatically. If we're using stateful set, I have to actually define where I want those volumes to be managed. So that's done through the specification, whether that be a deployment or a stateful set. Yeah, if you're using Helm, it's going to do that for you. You just tell it the storage class. Thoughts on the argument that Podman or something like that should replace Docker as an alternative runtime? I've heard the argument, especially in Red Hat RPM space. So the Podman and Docker follow the same syntax. The Oracle Cloud actually is going to Cryo, so different container platforms using different Docker images, but they all subscribe to the same standards there. So let's say that's done. Okay. Christos, there are first-party images for MySQL, Postgres, and most other DBs on Docker Hub. However, if you go to the Oracle link, yeah. So you can create your own Docker image. I would always go to the container registry. So don't go to Docker Hub anymore. Go to the container registry and use that. For most people, the image is there for 19C and for 21C on the container registry would be good. You only need to use the Docker scripts if you're going for images that aren't generally available, like 12 and 11 now, or you're looking to add additional database features which aren't included in those base images. What we're seeing as well is some people want to make the image a bit smaller, so then they take the Docker build scripts to create a custom image. Just compare these: Docker Hub, Search, MySQL. So if we're looking for containers, there is a site for database operators. There's 38 database operators there, operator.io. Oracle hasn't released its operators to that site yet, but it will do. There are multiple operators for MySQL, multiple operators for Postgres. But it's more than just having the operator. You need to understand the features you require. So when not all of the operators are the same, so look at the versions it has, look at some of the features, the non-functional and functional requirements that you have, and see whether those are supported in that operator. So you may want to have scaling, you may want to be able to scale out, you may want to be able to stop and start a service. Not all of them good. You may want to do rolling upgrades. So you need to look at the database as a service requirements, look at the business requirements, and see whether those features are supported by the operator. So MySQL or Postgres, the Enterprise DB have a Postgres one. There's also Percona and other Postgres ones. They're all slightly different, all have slightly different topologies, all have slightly different services available. Does your database operator support encrypted connections? Does it support encrypted storage? Does it support encrypted backups? So have you got security requirements? You need to understand those. Do you have some operational requirements? Do you need to stop the database because you want to reduce CPU costs at a particular time? So understand the business requirements and overlay that into the features that the different operators have. So in the chat box, anything there? So no. So Christianos, are you happy with those answers? Yeah. So yeah, thank you for sharing some of your searches on Docker Hub. So that's for Docker images. But if you're deploying in a container, in a Kubernetes environment, I would suggest going to use a database operator. It's going to give you that life cycle management, which makes it a little bit easier. It takes a lot of the heavy lifting away from you, like Helm. We're using Helm charts to package it up, or an operator. We can do everything through stateful sets, everything through deployments, but you have to work a little bit harder.
Wonderful. Thank you, Ron. Looks like we have we are ahead of schedule, and maybe we'll wait a couple more seconds for more questions if there is any. Well, in that case, please do reach out to Ron through Twitter and look into the blog post, and we will continue in this same track in 15 minutes. Thank you, Ron. Have a nice day and the rest of the session.
Okay,
Conference.
thank you. Thank you for having us.